Alright, boys and girls, today's lesson is lesson 2-1, Arrays and Area Models. So today is our first lesson that's going to lead us to multiplication. So we're going to kind of give you a visual of multiplication, kind of where multiplication came from. And next unit, our next lesson, we're really going to start digging into multiplication. So I want you to write down a couple words I have up here. One is array, and the other is area. I want you to write them somewhere down in your math journal. And square units, if you want to write that too. We're going to get to that towards the end of the lesson. So I'm going to do most of my lesson with this little board of circles, or dots, however you want to call it. And we're going to talk about area and arrays and square units all with this. And then the workbook pages will actually tackle those, or at least the second one will tackle in small group. So if you take a look at this square of circles, or whatever you want to call it, you can start thinking of it as an array. Okay, there's one way to look at it. You can look at it as if it's a 1. I'm going to start count all the circles on top, which there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I'm going to count all the circles on the side too. And I'm going to count the same one that we already counted for the up and down. I'm going to count it again for the left and right. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this array is actually, I'm going to erase all this because I counted it was 10 by 10. This array is actually a 10 by 10 array. So when you call it 10 by 10 array, it'd be called 10 times 10, which we all know 10 times 10 is 100. Okay, so this array would represent 100, 10 times 10. Okay, we're not quite in the square units yet, and we're really not into area just yet. We kind of are, but when we represent the dots and how many dots there are, right now we're showing you it's some sort of an array. This is a 10 by 10 array. Okay, so if I wanted to take this array and find let's say find 12 of them on here. There's a couple different ways you could find 12 by using another sort of array. I want all of you to kind of draw an array of 12. Okay, so if it were a multiplication problem, there's 3 ways you could do 12, but we're going to talk about 2 of the ways, because one of the ways you could do one row of 12 equals 12, but that's a boring array. So another way you could do 2 by 6, that equals 12. 3 by 4 equals 12, and that's it for those. So really these are the 2 ways you could make an array of 12. So let's do 2 by 6 first. So we can either do 2 on top or 2 on the side, however we want to do. Let's do 2 on top and 1, 2, 3, 4, 5, 6 on the side. Okay, so knowing that we're going all the way over for these 2. Okay, we're not just counting the one dot, we're counting 2 dots. That means we have to count 2 dots all the way down till we get to the 6 that we said 2 times 6, the 6 on the left. Okay, and the same goes for the 6. We're not just counting the first 6 dots. Okay, we're counting the first 6 dots all the way across. So ultimately we have an array of 2 by 6. Okay, it's a 2 by 6 array, which equals 12. Let's show you the other way. 3 by 4. 3 by 4, we take 1, 2, 3 by 1, 2, 3, 4, and that we just would take a look at how many we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because we have 3 times 4. Another way to represent 3 by 4, same way as 2 by 6, is you can do it the opposite way. You could do 4 up top, 2, 3, 4 by 1, 2, 3, and that would give you, if you count them all, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a 4 by 3 array, 4 by 3 equals 12. Okay, so let me erase some of this stuff for you. And I want to start talking about area. Area is I guess a little bit different. Area is everything on the inside. You're going to work later in the year. You're going to work with perimeter and area, and perimeter and area is actually they go hand in hand, but yet that means they go together. But perimeter is the outside and area is the inside. So if this were the yard, we would try to figure out how much area is on the inside of the yard. Okay, so that'd be the total area of the yard. So in area, you start dealing with square units. But in area, it's not exactly the dots. Okay, what we're going to do is we're going to create lines in here. That's 1. Here's 2. Here's 3. Here's 4. Here's 5. Okay, I have 5 lines. I know it's 6 dots, but I have 5 lines. Okay, 5 complete lines. Hopefully you see them in there. Okay, I'm gonna do a 5 by 2 array. Okay, here's 1 line. Here's another line. It's 2 lines. I know it's 3 dots. Now we kind of have to get that out of our head because we're talking about area now. So when we're talking about area, we're going to talk about squares. And then we're going to fill it all in. Okay, we're going to go all the way over to where it ends with the 5. And here's the 2 again. And then we're going to fill it in here. And what we're trying to do is we're trying to find how many squares we have here. Okay? If this is a 5 by 2 area, okay, if it's 5 by 2, it would equal 10. Okay, let's count how many squares we have in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what we have is we have the area of 10. But 10 what? 10 what? If you look at these, you'll see it's 10 squares. So here's where we get to square units. These would be 10 square units. Okay? If we were saying each one of these lines represented 1 centimeter, then our answer here would be 10 centimeters squared. Okay? Because square units, the unit is centimeters. Okay? Because I know in a little bit in 3rd grade you should have touched a little bit on area. But I don't want you to think too much of these dots here. So what I'm going to, these dots, because they're going to throw you off if I'm talking about an array and then I'm going to area. But the area is the squares. Okay, how many squares can you make? Okay. So what I'm going to do is I'm going to get rid of a lot of this. I'm going to shrink it down, get it out of the way. I love that. And I want you to turn to page 41 in your activity book. Okay. So if we talk about array, it says the number of unit squares in an array of connected unit squares. See, the reason why this was an array and it was a little bit different is because there were dots, and then I turned the array into an array of squares. So we can still talk arrays, we can still say array, but I don't want you thinking that it's dots. It's squares in this case. So it says the number of unit squares in any array is connected unit squares is the area of the rectangle formed by the squares. Okay, we did something very similar on the last one. If you have 3 columns of 2 rows, see we have 1, 2, 3 columns, 1, 2 rows. Okay, this is essentially a 3 by 2 array. Okay, because you have 3 squares on the top and 2 squares going down. Equals 6. Okay, if it's area, it'd be 6 square units, because if you look at it, we have squares. They're perfect squares. 1, 2, 3, 4, 5, 6. Okay, another way to look at it would be to look at the next picture. Okay, if we just added everything up, it would be the perimeter on the outside. 3, 6, 7, 8, 9, 10. But we are talking about the inside. Okay, the inside is a little bit different here, because the outside sometimes, most times, or a lot of times, the outside will actually be bigger. The perimeter might be bigger, because if it only has a little bit of squares in the inside, the outside might be more. So if you take a look at the second picture here, you have 3 by 2. Okay, 1, 2, 3. It's telling you 3 lines by 1, 2 lines. So you really don't need to go 3 times 2 times 3 times 2, because what these other numbers here representing the same exact thing that these two numbers are representing. Okay, so that still would be 3 times 2 equals 6. We're not talking about any types of units here. You know they're going to be square units, but we don't have any units named. Now here, on the next one, it talks about a unit. It talks about centimeters. So it's actually 3 times 2 equals 6 centimeters squared. I know we don't see the squares inside, but if we did perfectly separate this, you would see 1, 2, 3, 4, 5, 6. And don't think that just because there's another 3 and a 2 and a 3 and a 2 that you have to multiply them each time. Because that's what we're essentially doing here with our square units. We're telling everyone that it's a 3 times 2, but what we're representing is 1, 2, 3 on the top by 1, 2 on the bottom. So that would be the whole square, a 3 by 2 array. Alright. So a 2 by 3 rectangle has 6 square units in it. So 2 times 3 equals 6. When we get to our small group, we will work on number 1 and number 2. But the main thing I wanted you to notice today, and know today, was an array. An array, just to know, an array has rows and columns of objects, whatever objects you want them to be. If you're talking about square units, we did squares. If you're talking about just dots, we did just dots. Somewhere in here. Having issues. Okay, so we did just dots on that. Okay, also an array, you have each row has the same number of items. So each row has the same number of items. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, that means each of these have 3 in them. Up top, each will have 4 in them. See, this whole row has 4, 4, 4. This row has 1, 2, 3, 3. They all have 3. Okay, so this would tell you it's a 4 by 3 array, which equals 12. But if you look here, we have only 6 because right now we're counting just the dots. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We're not looking for area here. We're just looking for an array. So we will be working on, okay, that's a problem. I need to shrink this thing out. That's what's causing all the trouble. Alright, so we are going to work on the last 2 questions on page 41, and then we're going to work on 42 in the small group. So make sure you have your books with you.